okay? And knowing which thing gets broken down into what. The 1,4 versus the 1,6, I'm not so caring. I mean, if it helps you to think about why that's the case, that's totally fine. But I'm not going to go specifically, I'm not going to say, so amylopectin has 1,6 bonds and amylose has 1,4 bonds. I care more that you understand the concept behind why we're getting stuck with the amylopectin, okay? All right. So, this is all happening in the lumen. Now, once we get these pieces, these maltose, these maltotriose, and these alpha-limit dextrins, how do we get them so they become glucose, galactose, and fructose so that we can take them in? Now we're moving to the brush border membrane, or the apical border. When I say those are equivalent. Apical meaning toward the side of the lumen, brush border meaning that's description of the, little parts of the hair. Okay, so we have a couple of different enzyme systems. They exist in pairs except for trehalase, which is why we talked about trehalase before. So, we're on the alpha glucosidases. Again, we're talking about alpha bonds, which is why they're called alpha glucosidases. We're breaking that bond. The apical membrane of the intestinal epithelial enterocyte. On that squiggly thing. There are two domains per molecule. Okay? And by molecule, it means that these two enzymes are attached together to make one big molecule with an enzyme. So there are two active sites in this giant multi-active site molecule. That's different than amylase, where there are active site subsites, right? Where the active site requires these 5 to slot in the same way. These are two different enzymes that have evolved in such a way that they are attached together because it's evolutionarily advantageous to be able to break down these molecules. See the difference? Okay. All right, so we haven't talked about KM.